You're not seated in the order of the pictures, but I think people can figure this out as I read the names. First, I'd like to introduce Himanshu Tyagi, who's a co-founder at Sentient. Then I'd like to introduce Naveen Durvasula, which he told me how to pronounce it in the green room, and I'm pretty sure I already butchered it, but thanks for your patience. He's the chief researcher at Ritual, and he's not the moderator. That's a typo, excuse us. We also have Jasper Zhang, co-founder and CEO of Hyperbolic. And finally, we have Zhao, chief scientist at Nesa. And then actually, finally, we have our esteemed moderator, Gil Rosen, who's a managing partner at Blockchain Builders Fund, and also an organizer of this event. So without further ado, please give it up for our crypto and AI panel.
So this is fun, because blockchain is one buzzword, AI is another, and you put them together, and you get this stage right here. There's a lot of excitement, there's a lot of skepticism in kind of this intersection. I was having some fun conversations with a few of the crew here earlier. I'm someone who, like in 30 seconds, I believe AI will break the world and blockchain will save it. But for us to get from here to there, we've got quite a ways. So everyone here has kind of like disparate projects. I think it'd be great if we could start with just having you give a 30-second overview of your project, and then I think in blockchain we often like to sell things that aren't real. So to make things concrete, if you could also just like give one use case that is either currently live that you think is representative of why people should kind of be leveraging and using your platform protocol, and if it's not live, that's fine. You know, one that you would foresee to be kind of like a canonical ideal use case. So. Himanshu, let's start with you.
Yeah, it's a very combative start. Okay, great. So, great to be here. I'm Himanshu. I'm one of the core contributors for Sentient Protocol. And Sentient is bringing back what was there in 2018-19, basically community-built AI. And we want to pick up from where OpenAI left when they started closing. So we still believe that OpenAI in the form it was then can be monetized. So we are building community-built AI, and we want to build ownership and reward systems back to community contributions. That's what we are doing.
And a use case?
Use case is any use case of AI. There is no, like, AI is like every use case of AI is the use case. We want to build regular AI and compete on model companies. Like Sentient is a model company where it's with community contribution-based models. I don't know what use case to say more than that. We are targeting any use case of AI. In fact, we have already started a very heavy integration on the BD side with regular AI user company. So we'll talk about it. We'll talk about it. AI use case, there is no shortage, actually. The good thing about AI is that it's man, woman, child, and all the companies in the world. Right now, there's still this huge FOMO. I don't know, this week may change something. But right now, there's still huge FOMO for every use case to adopt AI. And there's room for everyone to jump in there.
Awesome.
Hey, I'm Naveen. Thanks for having me, founding member and researcher at Ritual. At Ritual, maybe our goal is a bit broader. It's to essentially create a chain that supports the execution of transactions that might require specialized hardware. Decentralized inference is obviously a big part of that. Of course, inference transactions might require a CPU or GPU that's well beyond what existing chains are capable of handling. And so maybe an end game goal for Ritual is to become the Schelling point for essentially all types of heterogeneous and open source computation.
Cool. And use case?
Right. So yeah, again, use cases are very broad. I think there is two concrete things. We have a network called Infranet that currently is running. There's a few thousand nodes running on it, and it essentially allows folks to query certain open source models and get results back. That's kind of an example form of heterogeneous compute. But yeah, on the Web3 side. What we hope to do is eventually allow folks to create smart contracts that have arbitrary queries to ML inference or any other bespoke hardware. And on the Web2 side, of course, like things are a lot more competitive. There are many forms, but if we could become the primary means by which folks query open source models, I think that's definitely the goal.
All right, thanks, Naveen.
Hi, everyone. This is Jasper, CEO and co-founder of Hyperbolic. I did my math PhD from UC Berkeley, won a few gold medals, and worked at Citadel and Ava Labs before I founded Hyperbolic Labs. At Hyperbolic, we're building a decentralized AI cloud to bring open access to AI. And ultimately, we want to build an open ecosystem and economy for AI, along with all the people working in this space, like Sentient, Ritual, Nesa, and other projects. And we're solving three major problems. First, we're building a scalable system to aggregate heterogeneous compute, and we're building AI services to maximize the performance of different kinds of GPUs. Second, we're solving the verification problem of decentralized AI. So we invented a new verification mechanism called proof of sampling, partnered with researchers and professors from Columbia and UC Berkeley. And lastly, we're trying to solve the privacy problem to protect users' data. And in terms of use cases, we have launched our decentralized AI inference live for 3 months. And we supported most of the state-of-the-art AI models like Llama 3, 4-5 billion model unquantized version. And we have the Flux model. We also have the Llama 3 base model that is very useful for AI research. So we have seen a lot of adoption in traditional AI researchers. If you just search Hyperbolic AI, you will see a lot of AI researchers tweet about us. And very soon, we're going to launch our GPU marketplace, which allow people to contribute GPU as well as rent GPUs from Hyperbolic. We have the waitlist live right now, and feel free to go to our website and sign up for the waitlist.
So last but not least. Perfect. So this is Ryu. I'm from NASA. And first of all, NASA is a science-driven firm, which means half of our team is from universities as a professor, including myself. So basically, NASA is also a decentralized inference platform. But differently, in addition to bring down the cost for large language models and other foundation models, what we actually emphasize is on the private inference, which means we really care about the security and privacy of the data, which means when you send something to the platform, whichever the platform you're using, ChatGPT or other things, we want to make sure nobody can see your data, which means including yourself or any centralized players. So along this stream, we actually innovate a lot of security and privacy technologies, including how to make the trusted execution environment available in this specialized decentralized environment, and we're also doing something like differential privacy and etc. to make this a strong case. So of course, just like the other fellows, we believe that AI models can be very useful in both Web 2 and Web 3. We're still in the test and net stage, so we are going to release more interesting information very soon. Thank you.
Awesome. Now, one of the reasons I keep harping on use is because ultimately I think blockchain often doesn't make things easier, it makes things harder, right? And AI seems to be challenging enough as it is. We have kind of a myriad of various generative models, et cetera. But if we look at what adoption is and how often it's actually used in enterprise, there's support, there's very specific use cases, and then there's the generative AI type things. But now we're adding another layer of complexity to it, and usually there's some trade-off. So would love to have you guys discuss a little bit, there's a Web3 side, which we're seeing, we're seeing gaming, generative content, we're seeing trading in DeFi. Then there's the Web 2 side where you're competing with all of the other Web 2 folks, and a potential value proposition some of you guys mentioned might be trust verifiability, might be privacy. Would love for you to touch upon a little bit kind of where you're looking to focus and what from a technology perspective you've built to kind of enable that.
Should I start? Okay. Yeah, so I completely agree with this part. If you want to have a production-grade, customer-facing AI app, then it's very difficult right now to have verifiability in it. If you really need it, maybe latency is not your issue there. So for Sentient, we are from day one going to position ourselves as a model company. And when we put up those models and we start looking at a few applications, start building the reasoning layer for those applications. Now, last week, a new name came for this cognitive architecture name has picked up now. I don't know, these names keep on dropping. AI is a bigger meme than crypto, by the way. So this cognitive architecture, the so-called cognitive architecture, basically they are specialization of the underlying LLM with the system 2 of thinking with this reasoning layer. So this is the path we are taking. This is all AI story. So where does the blockchain come from? We want to do this with community contribution. In the beginning, we are opening it ourselves for contributions. For example, the libraries that we feel can contribute here, the groups which contribute can contribute here. We ask them to filter data, refine data. There were several successful academic projects run at universities like Datacom, for example. I think Havana, for example, is also doing a similar thing with data. Some of those people have joined our team. In fact, one of the lead of Datacom is head of AI research for us. So we are building AI, but with community contribution. So for us, the tech part is, and which part can be slow, is when you have a repository, let's say just a model repo, and others are contributing to it, and its version changes. How do you ensure that the contributors' rights are kept maintained there, and when the model gets used, this guy gets rewarded? That's the piece of tech that we want to build. We have a name for this cryptographic primitive. We call it open monetizable loyal models. Open because you can download and run it. Monetizable because when you run it, unless you follow the protocol, we will be able to penalize you, so we can track its usage. Loyal is something we haven't at production grade achieved yet, but loyal means that you can't even run it unless we give you permission. And this can be implemented under different trust models. We are doing something very specific, which, as I told you, we'll be releasing this week in our workshop, which we are running on Thursday. So our protocol will release that, but that's the problem we are solving. We want to have this OML file format for models so that you can download this model and you can run it, and the protocol can track its usage so that it can reward the contributors for this usage. That's what we are solving. But the AI looks like regular AI. There is no, the AI is a regular model running on inference points, on Bedrock, and if these frameworks catch up with that speed, with that efficiency, for example, I would love to have a software layer like Bedrock sitting on all these decentralized offerings, and we are very happy to use it if it's there.
Awesome. I'm going to poke into that a little more in the next question. Thanks, Himanshu.
So, yeah, definitely agree. Trust and incentives are essentially at the core of this. If you think about an abstracted functionality of what a blockchain does, it's really just a trusted computer that anyone can run. And why would you ever choose to use this computer over a computer you already have? We have lots of computers. Your phone in your pocket is quite fast. If you think about early Bitcoin, all it did was add and subtract operations. Why use that instead of just your pocket calculator? The reason is that everyone agrees on the results, and as soon as that happens, you actually get some awesome economic phenomenon. With consensus, all of a sudden the results of those add and subtract operations become something that gets used as money. And as time has progressed, people's demand for what they would like to run on these trusted computers has become increasingly more and more heterogeneous. So after we just had simple transfers with Bitcoin, we ended up with arbitrary smart contracts. So our computer went from something that just does add and subtract operations to a Turing-complete machine capable of running programs. But of course, this computer is still quite slow, right? And we've seen what's changed in terms of what we can do between Ethereum and Bitcoin, right? But Ethereum is obviously still blocked from the fact that it's super slow, and you can't run transactions that require compute beyond something that essentially could have been run in the 80s, if not earlier. And so like going back to what we're doing for AI, like AI I think is one of the current use cases where higher level compute is required. And as we've gone from, scaling solutions have been discussed many times and continue to be discussed in native Web3 contexts. But there is essentially the question of why do you want to, how do you properly reward people for running computation, and how do you route computation properly? How much should people be paid? These are kind of the baseline questions that need to be figured out before anything like AI can run in Web3 context. So these are the types of problems that we're solving right now. We have, and it bleeds a lot into what people are talking about on the side of proven networks, rollups. Essentially being able to scale computation is a thing people care about a lot, and no one has quite rigorously just figured out like how do you price things properly, especially when there's very heterogeneous costs on the side of nodes, things for like very different demands across compute workloads, as well as what people's valuations for those workloads are. So these are the types of problems that we're working out.
And just like to quickly, from a go-to-market perspective, you're looking more at Web 2 or Web 3?
Definitely Web 3.
Web 3, right.
Yes.
And you guys like enable this kind of like easier
Right,
SDK
exactly.
for embedding AI into smart contracts.
Exactly. Concretely, like we will allow people to write smart contracts where through precompiles we'll be able to essentially run computation much faster than before. But maybe from a higher level, we're working on the market design to allow a permissionless group of people that have very different compute capabilities to all coordinate. And when workloads show up, highly intense AI workloads show up, there is an efficient way of routing those to the right people, pricing them, making the right payments, and so on and so forth. Cool.
Yeah,
Jasper?
For Hyperbolic, our first problem, we're trying to solve the first problem is trying to bring open access to AI, because we think like there are a lot of talented AI researchers and startups that are facing a critical problem, like they don't have access to GPUs, they don't have access to AI models. So we think about like, okay, what Web3 can bring, right? People talk about trust, verification, monetization, but besides that, there is another feature that Web3 can bring, which is aggregation of resources. Like everyone can contribute to this ecosystem by making the resources more redundant so that the people who need them can access it. And that's how we start with Hyperbolic. We're building this like decentralized AI cloud, which allow people to participate. But gradually, we realized that, okay, if we build this solid foundation, we can actually support a lot of Web3 projects as well, just like what Sentient is doing, right? They're doing this OML model that allow people to monetize their contribution. But then where are you going to host the AI models? We're going to use the compute to train a model. It can happen on Hyperbolic. And then our inference service can respect the contribution rule they set up, and then we'll redistribute the revenue coming into the inference back to these contributors. And then for Sentient, for Ritual, they're trying to bring AI on-chain. Then Hyperbolic can become the inference engine to power the AI on-chain, right? We can partner with Ritual. And then for Nesa, they're building like privacy-protected AI, which can also utilize our GPU network. So we see Hyperbolic as the foundation to support these different Web3 projects. But in the meantime, we're also trying to build our AI communities to allow AI developers to build on Hyperbolic. And hopefully, we can build an open ecosystem for AI developers to join.
Yeah, I think that's a very good point. So I can make comments on two things. The first thing is that why blockchain need AI. I think obviously we know that for many of the Web3 applications, we need to render images, videos, or your digital assets. So I think interestingly enough, like for now in the testnet stage, we're saying we're most used the models on our NASA network. It's it's image generation. We thought that should be language or something else, but it's actually image generation. So many of the Web3 applications will be benefiting from this AI models on the chain for sure, because directly you can access many of these AI models simply, other than going to the Hugging Face, download by yourself, running them, and doing the computation. So that will be one benefit, I think, that will bring to the chain by the AI for sure. And of course, why AI need blockchain? That will be a harder question, right? So other than people talk about like the payment reason, I think another big reason we are thinking we need to merge these two things together is because, as you can see, we're doing private inference, critical inference. We need to know how things are going, how people are doing the computation, who is running what. So for the bookkeeping and auditing purpose, I think blockchain play a very important role in this field. And I also believe like blockchain and AI, of course, two very hot topics. They will play some like 1 + 1 larger than 2 effect for sure. Thanks.
Awesome. Okay, this next one's going to be interesting. If you could briefly describe kind of the architecture of the project, right? And I say briefly because like you don't need to go into, we don't have enough time to go into like extreme technical depth here, but like the participants and the components and how they interact with each other, I think it would be great to just kind of get an idea of like, okay, well, how and who is interacting with the project itself.
I thought we'll start from that side. Okay. Yeah, so for us, in a simple picture, let's think of 3 participants. So the hero of the story is the AI builder. And AI builder is the one who starts by, let's say, a base llama model. And 4 or 5B, everyone is jumping about it. Let's start with there. And this guy puts that artifact out and starts that, let me start, let's say, fine-tuning that for certain use cases, and start looking for other data contributors to come and fine-tune it. That's where it starts. So it fine-tunes it and it submits it to our network to represent it in a particular format, which is what I was calling OML format. The network converts it to that format. After that, this artifact is available to be downloaded by the next character of our story, the AI user. AI user for us is not the end user, it's the application builder actually. This guy wants to download the model locally and host it and build on it. And this guy downloads and hosts and run it. And we want to do it in a way that when they run it, and this is the protocol that we are developing, when they run it, then they have to constantly get permission from the protocol to be able to run the model. And when they do that, then this revenue accounting can happen. And based on your contributions, you have a ownership share in the model and you get rewarded for it. For us, for simplicity, the base artifact is model. And you can think of data sets and you can think of code also as other artifacts. But current understanding we have is that everything is model. Data is also model. There's no difference between data and model actually. Data is model and model is data. There's no difference as such. So we just decided to start with just model as the key artifact around which monetization will happen.
Don't you have like RAG context data that can be used to like augment models, so to speak?
Say that again?
Like RAG data that can be
Yeah. So right now we are not monetizing the agentic framework, although that is another thing. Okay, one drop is that one thing we do is that all the prompt engineering and all the RAG, all the frameworks, we represent it as, if you want to monetize it, use a smaller model to represent that. So that, because we have basic technologies around a model, okay? So that's one thing we do. But one thing about this agentic frameworks and pipelines is that it's getting commoditized daily. It will be hard, we believe, to maintain a moat around any of these things. This is like a war and openly available. And in fact, we see a lot about what's happening here, but I'm very fascinated what Alibaba has been doing and what they have been making available for free. So I think these agentic frameworks, the RAG and all that architectural pieces, they will be readily available. Very hard to bring a moat there. So we still believe that the real tech mode that we want to focus on is the model itself.
Okay, gotcha. And it's actually funny, like listening to you guys, it feels a lot like digital rights management from the like music and
it is absolutely digital. It's okay. This is now come from this side. So this is digital rights management for the AI builder economy. Yeah. I am just super fascinated by getting a creator kind of economy to AI builders. Yeah. That's the goal, and that's what it is.
Yeah. Naveen?
So maybe I'll talk about how what we're doing fits in with the, I guess, previous evolution of blockchain infrastructure. So initially, when all transactions had essentially the same compute, they were all just simple transfers, we used to have our fees clear through a multi-unit auction. And the dominant design there was a first price auction. You pay your bid. Then that evolved we evolved from there to Ethereum, where you had smart contracts, and it became clear that not all computation was the same, right? We needed to price a transaction that had more compute. We needed to make that more expensive than a transaction that was cheap. And so from there, we had the problem was essentially what's called a knapsack auction, and EIP 1559 was the dominant design. Then from there we had, there's more heterogeneity in what people demanded. People have demands for storage versus compute. Blobs came about, and EIP 4844 was the next mechanism. So multidimensional fees, multidimensional knapsack auctions were the design space, and multidimensional fee markets were what people chose. Now that we're in this regime, when you have AI workloads and compute-intensive workloads, you have nodes that have heterogeneous costs. It's no longer a multi-dimensional knapsack auction or anything that we've seen before. It's a general two-sided marketplace where on one side you have people that are requesting transactions, and on the other side you have nodes that bear costs that are potentially very different from each other depending on the workload that they're executing. And so there's a general two-sided marketplace problem of how do there's two questions to answer anytime there's a marketplace problem. What gets matched to what, and how much are people paying? So people have tried to tackle this from various sides. The prover market folks have looked at this. Roll-ups have as well. What's really new about what Ritual is doing is we've actually gotten around a lot of the actually theoretical impossibilities too of two-sided matching, market matching problems. There's a famous result called the Myerson-Satterthwaite theorem about bilateral trade. We essentially introduce a group of intermediaries. These are kind of like, you can think of them as like brokers that are responsible for both determining the allocation as well as pricing between users and nodes. And through this competitive process, you can actually get hard formal guarantees about the allocation and the pricing being done properly. So that was all from a very theoretical perspective, but this type of vision is what we're currently building in production as well.
Yeah, for Hyperbolic's architecture, it has like 5 parts. So on the bottom is the decentralized orchestration layer. It basically is a layer that aggregates global GPUs, no matter it's from data centers, mining farms, individual machines, or on-prem machines. It can be orchestrated through our decentralized orchestration layer. And then on top, it's an AI services layer. We allow people to build different kinds of AI services. As a first party, we build a decentralized AI inference service that can optimize the performance of any kinds of GPUs. But we envision that in the future, other people can come and build fine-tuning, build training, RAG, vector database, etc., on top of our orchestration layer. And we have a verification layer which can secure and make sure the result is correct, generated by a random node. And we are going to have our privacy layer, potentially partner with Fala or like with Nesa. Together, we were going to build a privacy layer. And by having these like important pieces, we can make sure that any AI developers can come and build whatever AI applications that they want. So for example, one can easily build a GPU exchange. Basically, you can tokenize the usage of GPU, and then you can build a future exchange based on that. Or you can build an AI model monetization application, like just basically you can, as an AI developer, you can issue a token of the future revenue sharing of the AI model, and then people can buy those tokens. And I think there are a lot of projects working on that, and they can also utilize like protocol like Sentient to do more fancy monetizations and like rewarding real contributions to the AI models. So there is a lot of potential can happen on these applications there. And yeah, that's it. Like just 5 layers, and we welcome builders to come and build on Hyperbolic.
So at NASA, I think we streamlined the process pretty simple. So basically for the users, they just submit the data they want to use for the inference, and they pass the data to us. And on our part, we are doing more innovation, but I will explain this in a bit. So you can think in the middle is us, and then we just distributed this into the node runners to do the real computation. So the core innovation we're doing here in the middle, as the middle layer, is like doing 2 things. The one thing that we're doing is a smart model sharding. As you can say, for the foundation models, which are extremely large, they have dependencies. For example, there's tons of transformers within the large language models. How could you do the smart distributed learning? That will be something, it's important. It's also part of my PhD thesis a few years ago, not a few years, like years ago. That will be one part. We actually released a recent paper on how to do the model sharding for the large language models. That will be one thing. So we're doing the smart model sharding so that we can easily distribute it to the node runners to get the result efficiently. So that will be one part. Another part, which is a core unique value proposition we're having, is the privacy and the security, which means we're just trying to bring in the privacy and the security from the hardware and the software perspective. From the hardware perspective, which means if you have a secure environment to execute things on the node runners, we can make sure the user data won't be visible to anyone in this process. And we're also doing a software-based approach like a differential privacy and other things smartly, so that basically in the middle, we make sure the user inference request can be smartly distributed to the node runners, and also at the same time, we have this security and privacy approaches to make sure the data won't be visible to anyone. But as you can see, our model is pretty simple: user or self, and also the node runners. One thing I can bring on as well is because we need privacy because for many reasons, for the medical, for the healthcare, healthcare and medical the same thing. For the healthcare, for the finance, for the security, we need to protect our data for sure. But how much like security and privacy do you need is in your control. So basically in your user portal, you can choose like which technique do you want, and of course, more security you get, more thing you need to pay for that, right? Like the time, the cost of computation, but we leave this the flexibility to the user to choose. So that's our simple but useful models at NASA.
Awesome, yeah, and I think it's interesting because there's security and there's privacy and there's verifiability, but there's also on the verifiability side from a regulatory perspective, and we're starting to see this a little bit in New York already with some regulations around HR, that you have to be able to show that you've actually done something. So kind of zero knowledge approaches make a lot more sense. So we're just out of time, but this has been a lot of fun. I wish we had like another half hour. I think it's really interesting hearing about kind of like where you guys are focused on, whether it's the incentive structures to like bring people on board onto to incentivize kind of more model development and fine tuning, and then you kind of have potentially this cold start problem of like, okay, well, incentive structures work if you have people that are willing to pay, and then that can kind of incentivize. I think, Himanshu, you were saying that you guys are focusing a little bit more on the model side of things as well, and just creating good models as well.
Absolutely. So we are focusing on model creation, and we are curating in the beginning the use cases because we want to drive it from the usage side. Yeah. Because AI, you have that luxury. You don't have to hunt for a new use case. There are enough around, so we are starting with that.
Okay. And Naveen, you said something interesting of like touching upon like heterogeneous compute capabilities, and you mentioned that you look beyond kind of AI as well potentially. Where would you envision kind of looking beyond? And do you think that the network effects that you build with AI or that you're starting with AI would lend themselves to that, or would you look to kind of find some other, like another way to kind of incentivize people to come on platform?
So I think people are doing a lot of interesting things on the prover side or proofs as a service. There are various types of, so AI obviously is one people care a lot about in terms of an expensive form of compute that people want done. But even there are other, like even just running different types of algorithms that might be used for other applications. People might want that done off chain because it's too complex to do on chain, and so that might require its own hardware. So those are the types of broader things that our infrastructure would be able to handle.
Awesome. And then Jasper, on your end, you kind of have this full stack approach, but even though you have this full stack approach and you want to be able to enable people to kind of solve all of their problems, and you're going after researchers, which is very much a Web 2 kind of use case. It sounds like the competitive advantage that you at least have now is also around the optimization that you have of these specific models. Like, why are researchers, I guess, coming to you versus looking at the myriad of other like Web 2 options for like building out their models?
Yeah, so interestingly, if you look at the centralized solutions, they're still new. Like GenAI is only for 2 years, and they're still building their own infrastructure. And recently, there's a very interesting example, like Llama 3, 4.5 billion model. They just, it was released like 2 weeks ago. And at that time, if you look at the market, most centralized solution, they only have the quantized model, which is FP8 model. But none of them actually provide the FP16 model. And we noticed that there is a need from the researchers that they want to access the original model. So we hosted that for them. And I would say, like, although we're a decentralized company, we're also a very solid AI company. So we can host whatever AI models that the people want. And besides that, we can bring more access to compute, which gives us a better position compared to Web 2 companies. And we also embrace the open source philosophy, which wants everyone to contribute. And that can help us to build a much stronger ecosystem compared to centralized cloud. Yeah.
Okay. And last but not least, and I'll have to keep this short. It's like a lot of the value proposition that you speak about is again, it's privacy, it's verifiability, as well as performance. So it's interesting that the initial use cases are around like content generation, which I think like user-generated content in blockchain makes perfect sense because kind of you have this like long tail of things that people want to build. Do you think that that will be maybe that initial like primary adoption initially, or do you think that we're going to see more folks trying to use Nesa for use cases that require privacy and verifiability?
Of course, I think initially we're working with the Web3 applications for sure, so that image generation is very important. But of course, I think another major or primary goal will be working with the Web2 applications, especially we're just doing this with the medical and healthcare, because you can see the privacy in the patient's data, or even your personal assistant. You want to make sure your data is fully secure and private. So we can say there's a broader and a wide market out there in the Web2 as well. But for now, because you can see there's adoption cycle, so we're starting from the Web3, but finally, or in the middle, we're going to meet with the Web2 as well.
Awesome. This has been a ton of fun. I've run way over, but thank you guys. Really appreciate it.
Thank you.
Thanks.
Awesome. Yes, thanks. Give it up for the Crypto and AI panel.